Hi, Sportster Paul here. We're doing the third impression of BobCAD-CAM, a more inexpensive package than Hypermill. They didn't even want to talk to me. I said, is it over 10,000? They said yes. We've looked at SolidWorks CAM, which is made by CamWorks. We've looked at VisualMill. I'm getting to like BobCAD. I really am. The thing that's kind of making me iffy is the simulator. I just wish it had that compare button like the other two programs, SolidWorks CAM and VisualMill, and then it just shows you a graphical. Here's in red are the gouges and blue are the excess material, and you can set how fine you want to make that resolution. I just feel better about that. With BobCAD, you just get little text boxes all over your part. And okay, maybe it works, maybe it doesn't. But it seems to be doing everything it has to do. It's been fairly intuitive compared. I've been trying to use Mastercam, and that's been a real pain trying to understand all their conventions. So let's get to it. Let's shoot up here and look what we got. I've opened up SolidWorks. I've done tools. Oh gosh, I hate the scroll wheel doesn't work. Add-ins down here, turned on BobCAD. Loaded the part in. It's a long load, not as bad as Mastercam, which seems to be about a minute, but it's a while. It comes in. I immediately change the name of the part from test part -2. There, it's just when you want it to do something, it waits. Now it's thinking. The little arrow's flashing. There we go. So this is BobCAD 2. This is the way we left it, and I did add, I'm playing with it, I did a little facing here. So the first thing we should do is a save as, and you want to always save, well not always, but save as a copy and open. Save it as 3, this is episode 3. Save as a copy, open, we're in the right spot. CamQuest, yes, save. They're telling you it's demo mode, so what you save in this demo program will not open in a paid-for version of BobCAD. So there it is. Keep the original document open? No, we want to close that. Now let's come up here and, gosh, it's like they know just what your frustration level is and then make it appear there. BobCAD 3. And is it in the right spot? It's always a headache with SolidWorks, getting crossed up. And once I was editing, I didn't understand about this save a copy, and I had references turned on, and it was going back like 10 different versions. So I started with that part. Well, here's the tab for BobCAD. We did a facing. You can see there. The toolpaths won't show up. I've got them hidden with this little eyeball. The perimeter, we went around the outside. We did this deep pocket. We did this shallow pocket. To do the shallow pocket, like in the other two programs, I had to do a little sketch, a big sketch, and pave over these breakout holes. So right here, we had to make a sketch where there was a line here to go across that hole. BobCAD, unlike the others, got closer. It would have done this one right, I think. It just stops toolpaths. It's like it knows there's air there. Instead of trying to follow this arc like the other programs did, it kind of just stops and left a little cusp, a little fillet right here. And it would have worked here, but on this side, it left a little bit of material up here, and it depends how deep the drill is going to go. So it wasn't perfect. I figured, well, let's just go at it. So that's a shallow pocket. So I thought I'd start a little, save us some time. I said, well, I want to do this flat now. I said, well, maybe it's a face. So I went in face, I defined the depth, I picked this point and I picked this point. Obviously it wants to bomb through the entire part, right? I can't say just face this, which is what Mastercam loves to do. So what we're going to have to do is delete this if it lets us. We got something open? Delete. Oh, okay, delete it, yes. Let's start over again. Oh no, actually before we start, here's the problem. You can say, well, there's, select that face, make it a pocket. Well, it'll leave little corners here. I haven't found a way to say, go past, you can individually edit toolpaths, but to me that's bad practice. You want geometry driving the design, not individually edited toolpaths. Somebody will forget what they did, 10 years from now when they try to make another one of these parts. This part was made by my buddy Dave Rui, mechanical engineer, industrial designer, machinist. Genius, made to screw up. It doesn't do anything. It's made to screw up CAM. Automatic feature recognition has failed on every program I've tried it with. It just doesn't know how to deal. It does some of the holes from the top, some from the bottom, always does the pocket wrong. Can't deal with these breakouts where we had to draw a sketch. So the promise of all this automatic stuff, don't believe it yet. Maybe one day, artificial intelligence. So what I've had to been doing here is pick this face where we want to rough all this stuff out. That's the other thing to have a pocket. You want to rough down on it. You want something that you can do levels. And make a sketch rather than convert, what is it? Is it convert entities? My toolbars have changed. Oh, great. Here it is. Convert entities. Instead of doing that and then edit, it's just as easy to take here, go find this corner, make a pocket you know the tool is going to go past. Then say, okay, you drew the rectangle, then select that point. It's coincident. Remove that coincidency, and then you can stretch this one, and, you know, that'll probably get the job done, right? Waste a little time cutting stuff. I think that'll work. Then say, okay, get out of the sketch. Then I like to rename the sketch flat kludge, because this is a shame that I'm probably doing something wrong. I'm brand new at this. You're coming along learning with me. Flat kludge, and then we're going to hide it so we don't have to look at it. Go back to BobCAD. See, now it wants to say, oh, you've modified something. Let's recalculate everything. It's better than when SolidWorks CAM by CamWorks does it, because then it wants to recognize features again, and all the big giant 3/4 inch holes that I made routed holes, because my little mill won't make a 3/4, the chuck won't even hold a 3/4 inch drill. It puts them back in, even though I erased them the first time. So this one I don't think it'll do too much harm because we haven't done anything to affect toolpaths, but I just as soon say, don't touch anything. Don't help me. Don't do my thinking, do my work. So we're back in the CAM, in this tab. We go Insert, 2-axis. See, this is, you don't tell it ahead of time, oh, I'm trying to do a pocket, I'm trying to do this, and it makes it a little goofy. Then you can come here, say flat kludge sketch. Okay. Rough. This is a 4 flute. We want to do the 2 flute. Okay. We're going to let it rough and finish, even though it's kind of, look, see, it's using a 1/2 inch here. Maybe it's the first time it had this kind of geometry. I just don't know. Say, okay, now it's a 2 flute 1/4 inch end mill. In the roughing, I've learned if you wanted to do the guts, you don't want to just leave a little, just do a little perimeter around side. You got to say side roughing. I have tried to say just remove the stock. I'm doing something wrong. I don't understand it. I've had to put a step over. I'm doing 1/8 inch step overs, just real conservative. I think 5 of them gets the job done. I think, well, left this might not matter. Actually, it would. If you have this, system compensation means what side do you cut on? And if you change it, often it'll go right on top of the line. If you go to the wrong one, it'll do the outside. It'll go for 20 inches all around and hog through the part. They love going, all these programs seem to have no problem going through the part. We should be at a depth somewhere. Depth method, multiple steps. It doesn't know the depth. Where is that? Up here, feature? See, I'm getting to learn. It's not as annoying. Pick top, although it had the top correct. It never hurts to be careful. Pick bottom. This is similar to Visual Mill, and I love the fact that you can do that. Now watch the number. 3262, which I happen to know from doing this part in all these different packages. That's what we want. So we got that right up here. Then we go down to parameters, even depths, 2 cuts, 3216, yeah. Parameters, multiple steps. Go down 1.5. Let's do 125 again and see what happens. Okay, then it does 3, and then it has to look to make even depths. So I kind of like that. Wrong. Depth of cut 125. Just do what I did before, even though I know it's going to change. Okay, 3. So 3 passes down. I think this is the 2 flute 1/4 inch end mill. This is the same 2 flute 1/4 inch end mill. Let's say compute. That looks like what we need, right? It doesn't leave little arcs here because it's trying to do a pocket. Doesn't leave a little post here because it's trying to stay inside the pocket. I couldn't fix this in my rehearsals. It's plunging down into the material, and I'd rather have it come from the outside, right? I'd like it to come here. I couldn't find an easy way to do that. Let's see if we can, real quick, edit. We'll try, it won't be so big on, it's here, leads. Parallel, right angle. I would think right angle, let's go right angle, an inch. Way out, compute. No, see, it just moved it more to the center of the part. So it's always tough figuring how the software person thought of this. Where were we? Everything brings you back where you were. Patterns? What was I doing? Oh, lead-ins. Lead-ins. So this ain't happening. Circular? Well, maybe. Well, when I did a circular, when my testing where I actually cut some metal, the Avid Benchtop Pro that I got, which is a router style, it's stiff for a router, but it's not like a Kitamura or something. So when I was spiraling down, playing around, seeing how it cut metal, it sounded like it chattered more than when it just straight plunged. So you know what? I'm just going to leave it. Oh, it doesn't even give you a choice then. Compute. Let it go back and do its thing. I'm not pleased with this, but that's life. Meanwhile, a little housekeeping. You know me. Oh yeah, you can't hold and change. You know, everything's a little different. They haven't adopted SolidWorks or many program standards. You got to do an explicit rename there. Right-click rename. And this is the flat. Here. And file save, because thank you so much, BobCAD. Somebody at that company said, well, let's let them save it. We just won't let them open it in the paid-for version. So this has made doing these demos much, much easier. It's warning you. Okay, this won't open in a paid-for version. If you download the demo version, it'll open with all these toolpaths. It only posts 5 or 6 lines of G-code. You know, it might be good to see your part zeros are right, but other than that, not a lot. What do we want to do? I guess we're going to simulate now. Did we save? I'm already... oh yeah, because I gave my little speech about thank you, BobCAD, for saving. Simulate. There it is. I like to turn off the toolpaths. I've been doing next stop, next stop. There's... I really wish, I wondered why it goes there. Next stop is the deep pocket, the finish of the deep pocket, rough of the shallow pocket, finish of the shallow pocket. See, the buttons work different in the simulator than in SolidWorks for panning and zooming and all that. So that's getting close, right? Now we should see this flat disappear. We're wasting a little time machining there, so we'll say go fairly slow. See, run. See how it's plunging into the part? There's got to be a way to figure out, you know, it sees that rectangle, it says, oh, this must be a pocket. That's why I was hoping with a face. You know, when it does the perimeter, it comes from the outside. Of course, there, the cuts are on the outside of the rectangle you draw, not on the inside. So I guess when you're inside the rectangle, they're always going to plunge. I haven't found a way, but I'm a newbie. Not too cool that it's leaving these sharp things. It's fairly responsive. You can speed it up a little. Here we go. This is still a roughing operation. Nice gentle cuts for my router style mill. Down, down, down. It's deeper than I thought it was, huh? Why'd you go all the way through the table? Now it's doing a finish pass, see? And it's just not nicking that little bit of material off. It does 3, right? And it's wasting time. That's something that wouldn't be too hard to fix, probably. Do the finish separately or take the stock allowance off of the roughing pass. Like always in the simulator, you get these little what is that? Is that something real? I don't know. This is what I don't like. You can go verification, get a report, wait. Then it has no gouges, or that would have lit up as well. Show excess, and it just starts paving stuff that some of it is obvious, like, well, there was a hole there. Yeah, I'd expect there to be excess material. But what's okay, this might be because of the angles aren't cut yet. Compared to the SolidWorks CAM by CamWorks and Visual Mill, you press a button and it gives you a color-coded representation. That's what I like. But at least it hasn't gouged anything. That's kind of cool. Now I hope I can remember. That was the flat. It's blank unblank to hide stuff. When you're selected, it lights up the purple outline of the geometry it's cutting, which is kind of helpful. Like I say, I'm getting used to it. The problem is it intuitive? A Visual Mill was the most intuitive. Is this intuitive enough? So after I haven't used it for 3 months and I jump back on some hot project, got to get it done by the middle of the night, will I be able to remember all of this? Probably have to go watch my own videos to figure it out. Facing. Now we're going to do something fun. Something only BobCAD has almost pulled off. Just like it almost pulled off doing this shallow pocket, it almost pulled off doing these angles. Oh, by the way, the stock is blanked too. So if you'd rather see the stock, that might make some people happy. Let me think. Get down here because we want the operation to go after this one. Do a right click, 3-axis. Select geometry. I went here and here, and that's all I had to do. In SolidWorks CAM, when I selected this bottom one, it drove the ball mill a little further, but that's life. So we'll say OK there. Machining strategy. Okay, can we take them both out? Yeah, I guess it does. I tried equidistant first, and that makes little trapezoids over the angles, it goes around and around, little circles. No, not a circle, but, in a boxy shape. And then, I saw Z-level finish. I saw advanced. Well, that's for me. Let's do the advanced one. So when you do this now, when I click these, I'm trying to point at the screen for you. This Z-level rough and that planer should disappear, right? Go to posting. Okay, now it changed to advanced Z-level rough. So this is this whole wizard thing they're so big on that I'm not too thrilled with. Here, tool crib. What did I have to do here? It was add from a library, go all the way to the end. The only ball mill I found was this 1/2 incher. Say OK. Say OK, and then watch how nice this is. Change it to a 1/4 inch. Be sure to change cut the radius in half, or I think it blows up. I don't know if it crashes. 2 flutes. Lengths are fine, I think. It could be shorter, but let's not. Oh, and let's keep your documentation good. 1/4 inch end mill. Next, it goes down. Pattern, zigzag, parameters, machining tolerance, depth of cut. I know I want a lot of these. I want to do it just like we did in the other 2 programs. 10,000ths, real fine. Lots of little cuts so that ball mill barely leaves the scallop. I think that let's go compute and see what happens. It thinks, huh? Oh, that's pretty cool, right? Now, here's the thing. 18 minutes. I think we'll have time to show you this. We're finishing up the top today, so that's good. How can I show you? We go into the simulator, and it's smart enough to let us save. Yes, save. Yes, it's a demo program, we understand. Visibility, hide those tool paths. Start running through the operations. And in that last episode, see, if you go fast forward and you have a tool crash, it skips over the tool crash and doesn't tell you. So at least once for every tool path, you should be doing the run and watching the pretty little animation. That's kind of a shortcoming as well. Where are we now? Next stop, next stop. There's a shallow pocket. Here's the big flat. Now I think, see, the middle button doesn't work in the simulator. It's the left-hand finger that makes it do this. All right. Panning is the right-hand finger. Well, I like that, but can't make SolidWorks do that. Run. It's wrong tool. Oh, no, this is the finish. I'm sorry. So this is the finish of that flat. It's kind of goofy. It's got to run. Now we should see it change. There's our ball mill. That's not too bad, right? but you're going to see the problem with this, and it's the same problem the other. Collision between tool flute park and stock. That's concerning, isn't it? So, last time we fixed this, of course this didn't happen in all the rehearsals. Of course. Oh, housekeeping. You want to call them slopes, angles, slopes, ski slopes, and do an edit. Last time the thing that kind of helped, let's go up a half an inch. Go way high. Feed plane. Come in slow. Go in slow. Half an inch is above that whole depth. That was what, 0.36 or something? Compute. See, everything jumped up. Let's see if this crashes. And of course, this wastes more time because you're slowly going through, but this is just the principles, right? File, because it does crash. The more stuff you get going, the deeper you get into stuff. It doesn't crash as much as Visual Mill, which is unusable on this machine only. Windows 7 with an installation problem. Okay. Simulator, here we go. Next stop, next stop, next stop, next stop, next stop, next stop, next stop. Visibility, turn off the tool pass. Next stop, next stop, next stop. Okay, there's the ball mill. Oh, God, I wish this thing would work the way SolidWorks works for panning and zooming. Your fingers start to hurt because you're pressing harder. When it doesn't work, you don't realize it. It's like psychologically, you're like, ah, and your knuckles start. And then the night after I mess with this thing, my knuckles all hurt from pressing on the mouse because nothing works the way it does in SolidWorks, and you're in SolidWorks. All right. So what are we going to do? We're going to see if we get that crash again. You can speed it up, I guess. See, lifting up a little higher seemed to do the job. Now, two problems. Once again, problem one is it leaves a really big scallop here because that face being defined, they go vertically up from the edge of that face, like where this face meets the sloped face, and they don't let the center of that tool go any further. So what you're seeing is the center of the tool right at this point. You could see if they let that tool come down, it would do much better. Same problem over here, real big scallop. All these programs had it. Some I drew a little sketch down here and added that to the geometry, and then it followed all the way down to the bottom. I think SolidWorks CAM, I just had to select this face, although it might have gone and done a bunch of other needless stuff. Next problem. Oh, it's happened. We've already, this I didn't notice, happened here. There's a little gouge here. That's interesting. Got to figure out what's going on. See, but it won't report that as a gouge. That's one of my problems. Next problem is there's extra material. You can see it right here. And this is the genius of my buddy Dave, who designed this part to trip up CAM. Having this angle, so this is a trapezoid, it's not a straight rectangle. There's something about the math. All the programs have been doing this. SolidWorks CAM, I extended the radius of the entry and exit. With Visual Mill, I may have... Oh, Visual Mill, I think, had a way to extend the tool paths. First thing I want to do, show you, how are we doing for time? Not too bad, actually. Oh, gosh, verification. You get dialog box dizzy. See if it picks up that gouge. See, no gouges. That's a serious problem, right? To me, that you can see it. Right? That's a real thing. Right? That's a real gouge. And I wasn't smart enough to see when and where it happened. What do we want to do? Go back to the simulation. Go previous operation. Why are we still doing verifications? Restart, like everything in software. You just got to start. And where is it? Here it is. Next stop, next stop, next stop. Come on. Now I think we'll slow it down a little. And we'll try to look. Oh, come on. God. Sometimes it's thinking, you know, it's doing some goofy thing. Run. So it's doing this one. It's coming down. This might be something you could fix with entry exit. Okay, so we can speed this up. This is why you want a really good simulator and one that you can navigate. I wasn't too happy with SolidWorks CAM, the speed up, slow down. See what it did? It made a little circular thing there. All right, well, we know what to look for. Come on, go home. Have we saved this thing yet? Save. Thank you, BobCAD, thank you. Oh, well that, why? Why on earth? And here's the problem, it's not an entry or an exit. That's something unique to this one. Well, let me show you. At least I can fix this bottom scallop and this problem here. And BobCAD's been the only one I found. And I'm an amateur, so don't blame the other programs. Aren't we in the simulator? No, we went out of the simulator. See how confused I get. You go, slopes, edit. Was it patterns? Rough. Machining strategy, feature. There's something about 3D, advanced feed rates, gouge check, links, options. Here we go. Cutting extents. Because, you can see how things get kludgy. The software tries to put things in orderly little boxes that they've decided the way the world works. And then let's do 3D. And then, okay, we got to have an options thing for this. 3D extents. I think center of tool boundary options are okay. Compute. See how it stretched everything? So, see now I'm in SolidWorks. So now the tool paths go down to the bottom, right? They go all the way down here. And I'm pretty sure this also clears up on the side a lot. Oh, come on. How can I show you? I think the fact that it overshoots here, and it's actually arcing down. Now, here's the problem. I don't know how to fix, this would have to be, we'll go, how are we doing for time? We're running out of time. File, save, yeah, simulate. Let's do a fast forward. Bang. Visibility, turn off toolpaths. Now you can see, even though this is not a pencil mill or an 1/8 inch, see those scallops are much less. And you can also see there's much less excess material here. There is, however, the gouge. There's got to be something, why it makes that little curly Q going down to do this second. I don't think entry, exit are going to fix anything. Let's get out of here. Here's the issue. It gouges right there, coming down. Is that slopes, edit, leads, lead out, same as lead in, vertical, parallel. Vertical is a good thing to question. Let's try right angle. Let's just let it default. So it comes in, but it's still, I think, going to do the gouge, right? Because that's the point. Whether it comes straight down, it's the fact that it's at this point in space. So what you hoped would fix it won't fix it. Leads. Parallel. Compute. No. Oh, look at this. Now it plows into the part. Well, always leave it in a way that's you kind of understand how screwed up it is. Okay, vertical, finish. I didn't redo tool paths. I keep doing that. Compute all tool paths. MasterCAM has this concept about it's a dirty tool path because something's changed and you haven't regenerated it. I kind of like that. Well, it's, once again, close, but I wish it wouldn't leave that gouge. Let's simulate. I'm pretty sure. Have I shown you this? Fast forward. You got to let it think a little bit. Oh boy, oh boy. It's a shame. And visibility, turn off the toolpaths. Come here and do this verification. Gouge in excess. We should see a gouge and it won't. Watch. Yeah, see, no gouge. So it's getting fewer and fewer, and that's what I like. By the time I was done with the part, in rehearsals, I've gotten through the whole part. And that's when I started saying, you know, BobCAD isn't too bad. It leaves where the holes are, right? Where you'd expect. Well, we haven't come from underneath and done the holes. Of course, there's excess material there. So, not too bad, but I wish it wouldn't leave that little gouge. That's what I wanted to try. Where do you get to edit toolpaths? Is it in here? I thought maybe I'm confusing a different package, right? I've been doing so many the last few weeks. Options, links, advanced feed rate. No. Boundary, geometry, oh, here. Gouge check surface. Well, you didn't gouge check enough. Boundary. Finish stack. This might just be operator error. You know, it's just, why on earth would you make this little curly Q here and gouge the part? Like I say, programmers don't seem to mind running mills through solid models. Okay. So that's that for today. Not bad. We got the whole top of the part done, right? And close but no cigar. I guess the kludge way to do it, if there's no way to figure out how to fix that little curly Q that does the gouge, then it's going back and drawing a sketch that enlarges those angles, and then just telling it, it probably wouldn't have to be advanced Z, just a regular Z-axis rough, or equidistant goes in circles, so I prefer this Z-axis business. But looks pretty good, you know, and it's pretty close when you do 10,000 step overs like this. All right, so that's today. Next time we're going to flip it over, another setup, deck the bottom off. You know, it'll be held in the vise by the part itself. Deck the bottom off, shoot the 5 holes. And there's some, it always wants to make 2 groups. I found a way around that. It's a little tedious, but we'll get to that. Meanwhile, thanks for hanging in there. Catch you next time. Have a good CAM journey. Bye now.